Good morning, everyone. The creature I'm going to be featuring is the lionfish. Although we all know the lionfish is a voracious predator who seeks to destroy and kill every other small fish in the environment that it's invaded, new research has shown that we can actually utilize the lionfish as one of our many tools in nature's medicine cabinet, with research leading towards Alzheimer's and antioxidant, anti-cancer, and anti-inflammatory drugs. Native to the Indo-Pacific and Red Sea, the lionfish was originally introduced into the Northwest Atlantic Ocean by the aquarium trade. Tanks broke in a hurricane, and soon this fish became a staple of the local environment. The dense populations are in the Caribbean, Gulf of Mexico, and Northwest Atlantic Ocean, rapidly increasing over the last decade. They live in coastal areas and prefer shallow waters and will choose structure over any other suitable habitat. The lionfish wreaks havoc on all local environments, as it has no natural predators in this environment, and the only method of controlling it is diving with spears. The lionfish operates as an ambush predator, lying on the bottom of the seafloor or floating low to the bottom, waiting for prey to pass. Once this prey has arrived, the lionfish kills its prey, first by paralyzing it, with 17 different venomous spines, 13 on the top, 1 on each pelvic fin, and 3 on the anal fin. There are 2 species of lionfish in the Northwest Atlantic Ocean: Pitrellus volatinus, which makes up 93%, and is the red lionfish, which is most commonly seen, opposed to the Pitrellus milis, also known as the common lionfish or the devil firefish. Speaking from experience, almost every fish in the world will bite at a lure. However, with the lionfish, it's not possible. For some reason, lionfish will absolutely never, under any circumstances, bite a lure. That means swimming lures, topwater lures, lures that sit in the water, as well as live bait, or cut-up bait. Tried and tried to no avail, fishermen just couldn't seem to get their hands on a lionfish, outside of getting a lionfish on their hand, stinging them with the venom. Fortunately for us, as long as lionfish have been around in our environment, we have been hunting them. Decades of experience has given us one very traditional, but highly unconventional by today's standards, method of catching these venomous and absolutely irrational fish. This unusual behavior by the lionfish drove fishermen to create new tactics to retrieve these fish. Divers had to go down with long spears, equipped with 3 prongs on each end and a barb to prevent the fish from escaping. Once caught, these fish had to be transported into a zookeeper-type device, a big plastic tube with a mesh grate on the front to prevent these lionfish from coming back out. Once these fish were in, you could collect up to hundreds of them in each bin, bringing them up top to the surface to then put on a boat. This method was originally perfected by divers who actually worked for the food industry, as well as divers who operated on tourism or commercial diving. These individuals wanted to control the population around their reef, and worked in tandem with the food service industry to create dishes based on lionfish meat. Once the general population had gotten hold of how good lionfish meat was, there would be a sudden demand. We've seen this occur with Whole Foods, as they actually sell lionfish by the pound for $12 a pound in all their stores in Florida, although they can't sustain a supply chain to go any north than that at this current moment. For Alzheimer's research, the strong potency of the cholinergic venom can be used to counter the effect of the senile plates in the central nervous system caused by Alzheimer's. Mathematical papers stimulating chemostatic signaling and microalgia have both predicted this would be a successful operation when they are carried out. Both chemoattraction and chemorepulsion were discussed, and probability was higher with the microalgia. This paves the road for more biologically realistic and mathematically thorough experiments. Although there are chances that this experiment may not be true because of the limitations of chemical extractants and repellents, and evidence of their identity is circumstantial, but there are serious questions to be considered with this research before it is continued to carry out. Biophenomenons of inflammation and death of neurons, as well as the involvement of microalgia, astrocytes, and several secreted cytokines can affect this experiment as well, and research needs to be carried further in order for us to understand how well this venom can be to counteract the effect of the senile plates caused by Alzheimer's. On a more relevant note, in a biological experiment discussing antibacterial, antioxidant, and anti-cancer compounds, Pitrellus venalis, which is the common lionfish, the 93% one, extraction of the venom was carried out via Lowry's methods, using ethanol 90% and ammonium sulfate in 20, 40, and 60 and 80% saturations. These samples were put in 20 microliter samples and incubated for 10 minutes. A brine shrimp lethality test was used. Taking 10 larvae of the A. salina were set up in 1 milliliter of saline water with the addition of a different concentration in each experiment. After the brine shrimp lethality test was carried out, an optimal concentration of LC50 greater than 1,000 micrograms per milliliter indicated the sample would have potential as an antioxidant, anti-cancer, antibacterial, and antifungal remedy. This would then replace synthetic components in these medications and foods, and soon we could harvest a lionfish as a natural resource as well as an invasive species. Works Cited Part 1. Works Cited Part 2.